Hello all, welcome back to the series of data structures using Java. And in this video, we'll be discussing about deletion operations in singly linked list. So in the previous video, we have seen how insertion is happening in the singly linked list by 3 ways. Okay. So if you didn't see the video, please go back and refer that video and come to this. And coming to deletion in singly linked list, there are 3 ways of deletion in singly linked list, same as insertion. So here you can see deletion happening at beginning, deletion happening at end of the list, and deletion happening in between the list. Okay, so first we'll discuss about deletion at beginning. This is my existing list. If I want to delete a node that is present at the beginning, that is at the first position of my list. So how do I delete it? You can see if I want to delete this node, right, I should move my head pointer to the next node, because always head should point to the first node in the list. If I'm deleting the first node, obviously the second node will become the first node after deletion. So this head node should point to my second node after this deletion. Okay, so this change I need to implement when I'm doing deletion. So after deleting one, you can see this is my list where it has the node 2 and it has the node with data value 3, and now my head node is pointing to this node 2. Okay, because after deleting this node from the list, right? Now how do we implement that in the form of code? Okay, so here is the Java code. If you see here, before performing deletion, first you need to make sure whether the list is empty or not, because if the list is empty, you cannot perform deletion on the empty list, right? So for that reason, you need to check whether your list is empty. How do we check whether the list is empty? By checking the condition whether your head node is equal to null. If your head node is equal to null, then it means that your list is empty. Right? So you can give a statement like your list is empty. You cannot perform deletion in this. You can add your statement here by using this print statement, system.out.print. Okay. Otherwise, okay, what if your head is not equal to null? If there is some node existing there in the list, okay, in that case, what you have to do, you need to assign the next node of head as head node. Okay, because this is my head node now. If I'm deleting this head node, the next node of head node should be taken as head. So that assignment you have to do here. You can see head node of head node, that is head dot next, is assigned to what? Head. What is my head dot next here? C. That is the next node. So I have assigned head dot next to what? Head. So this head node will be pointing to this second node after deleting this first node. Okay, a simple logic, a simple code you need to write for deletion, for checking whether your list is empty. If it is empty, we cannot perform deletion. So you are giving some statement for that. Otherwise, what you can do, if the list is not empty, then in that case, you are assigning your head node dot next as your head node. So the next is deletion at end. Okay, so how do you delete a node that is present at the end of the list? If you delete a node at the end, then what changes you need to do? Right? So this is my existing list where the last node is having the data value 3. Okay, I want to delete this node from my list. If I delete this node, so what change I need to do? I need to do a changes here in this node. Okay, so because the next pointer is pointing to this node now, but if I delete this node shouldn't point to anywhere, because this will be my last node after deleting this node. So it should point to null. Right? So this changes I need to implement here when I'm performing deletion at end. So before going for deletion, what you need to do, first you need to find what is your end node. Right? For finding the end node, what you will do, you will just start traversing from the head node till last tail. Okay, so you will start here and then again you will visit to the next node, again you will move to the next node, like until your the node becomes null. You are going to traverse through the list in order to find the last node of your list. Right? So once you found the last node, then you have to change the address of your previous node. Okay, this is my last node I found, but where I'm going to do the change in my previous node. So the address of the previous node should be pointing to null. Right? So after deletion, this will be my list. Okay, now we'll see how to write a code for this. So when you're performing deletion, obviously you need to check whether your head node is equal to null. That is whether your list is empty. If your list is empty, you are saying your list is empty, you cannot perform deletion on that. Okay, otherwise here you are checking one more condition. What is that condition means? Whether your head dot next is equal to null. Okay, what is this condition? I'll tell you now. See, if my list is empty, okay, there is no node in the list at all, then your head will be pointing to null. Right? What if my list has only one node in it? Okay, and this node is the head node and it has some value. For example, let me take it as 1 and this is null. This is my list now. which is having only one node, having the data value 1, and the reference is address is null. And this is my head node in the list. Okay, so this is first case you checked whether your head is equal to null, that is empty. If it is not empty, you are checking the next condition. What is the next condition? Head dot next is equal to null, which means if your list is having only one node. Okay, if there is only one node in the list, that is what head dot next is equal to null means. Okay, head node dot next is equal to null. Yes, so the list is containing only one node. So if a list has only one node and you want to delete that particular node, okay, then what you will do? If you want to delete this particular node, you will simply assign head is equal to null. Right? If you assign head is equal to null, then this node will get deleted automatically if there is only one node in the list. Right? That you should keep in mind. So that is what you are checking the condition, whether your head dot next is equal to null. Yes, if head dot next is equal to null, then what you are doing, you are assigning head is equal to null. Okay, if you assign head is equal to null, then automatically this will be deleted from the list and you're returning here. Right? And if head is also not equal to null, and if your head dot next is also not equal to null, okay, then what you need to do? That is your third condition, third case. This is your third case. Okay, if both the condition is false, then you are coming to this one. Right? And what does this actually mean? Your head is not equal to null, and your head dot next is also not equal to null, which means you have a list which contains more than one element, one node in it. Okay, so there is a list which contains more than one node. It can be 2 or 3 or 4 or anything, but it has more than one node. Okay, so that is what this condition is saying. And in this, as I said when you are deleting, you need to traverse. Okay, when you are deleting the last node, end node, you need to traverse till last node. Okay, so what are all the changes you are implementing and where you are implementing? You are implementing the change in the previous node. Okay, previous node of the last node. So here I am considering two nodes. So first node is previous node. Second node is current node. The current node is pointing to head first. Okay, which means current node is pointing to the first node of my list. So I have taken two nodes. One node is previous node and the next node is current node. Now my current node is pointing to head. Okay, so now you need to traverse, right? For traversal, you are using while loop, current dot next not equal to null, true. Then you are going inside, and what you are doing here, you are assigning the current node as the previous node. See here, I have two node. Okay, so 1, 2. I have two node here, and this node is pointing to here, and this node is null. Okay, so now this is my current node. Initially, according to this statement, this is the head node and head node is pointing to current node. So this is my current node now, right? You are checking the condition whether current dot next not equal to null. What is current dot next? A, which is not equal to null. If it is true, you are entering into the loop. Now you are assigning your current node as previous node. Now this node is also becomes what? Previous node. So previous node also refers to first node now. Current node is also referring to first node now. Head is also referring to first node now. Okay, but this is not the node I want to delete, because you need to delete the last node, right? Deletion at end, you need to delete the last node. You're not going to delete this. So I'm not stopping here. I need to find the last node. Okay, so for finding the last node, you need to traverse, right? Again, what you're doing for traversal, current is equal to current dot next. So which means now this is not my current. This will become my current node. Okay, because I traversed from this node to this node by using this statement. So once my current node gets changed, what I'm doing, again I'm going back here. My iteration starts from here again, and it is checking whether my current dot next is not equal to null. What is my current dot next? It is null. It is not satisfying this condition because it is null now. If it is null, okay, then this block will not get executed, right? Again, this will come out here, out of this block. And what is given in the outside block? What I'm doing? Previous dot next is equal to null, because I want to delete this node from the list. If I'm deleting this node in the list, I need to change my address, this address, previous node address, as null. So now I found this is my current node. I have deleted, and this is the last node as well. So I have deleted this node from the list. After deleting this node, like when you want to delete this node, what you need to do? Your previous dot next should be assigned with null. So that is what I have given here. Previous dot next is equal to null. So if you assign this as null, then this node will get disconnected from the list. Okay, and then you will left with this node in the list. This is what deletion at end. Now we'll see deletion in between. Okay, so how do we perform deletion in between? And here this deletion is happening based on the data value. Okay, that is in this example, this is the list which contains 4 nodes. Okay, the node first having data value 1, then 2, then 3, and then 4. If I want to delete a node in between, okay, so for example, I want to delete this node having data value 3. Okay, so how do I delete this node? First, I need to find where is the node containing data value 3. For that, I need to traverse from first node. Okay, then I need to compare the data value of the first node with the value to be deleted. If it is equal, if it is matching, I'll delete that. Otherwise, I'll move to the next node. I'll traverse to the next node. Again, I'll compare the data value of that next node with the node to be deleted. If it is matching, delete it. Otherwise, move to the next node. Again, I'm comparing the data value of this node with the node to be deleted. If it is matching, delete it. Otherwise, move to the next one. So likewise, what you're doing here, again, you are performing traversal. While doing traversal, you're also comparing the data value of that node with the node to be deleted. So here I want to delete 3. First, I need to find where is my node having value 3. If I found the value 3, okay, I'm going to directly delete this from this list. If I'm deleting this from the list, what are all the changes I need to make again? Okay, I need to look that. So if I'm deleting this, for disconnecting this node, first you need to change the address of this node. Right now, the address of this node is G, okay, which is nothing but the address of this node, right? So this is pointing to this node, but if I delete this, where my pointer should be, it should be pointing to the next node. After deletion, the next node. What is the next node? That should be linked here. So now this G should be replaced with what? This G should be replaced with this M, so that this node will be pointing to this node after deleting this. Okay, but when you are assigning this M here, how do you assign M value here? Okay, if you take this node, the node which you are going to delete, this node already has the same address M, right, which is pointing to this node M already. So what you can do directly, you can assign this node address to this node address. Okay, the current node address you can assign to previous node address. Why am I saying this as current node? Because this is the node I want to delete. If I want to delete, I need to traverse. So when I traverse, I am finding this node as my current node. Once the data value I want to delete is matching with this data value, then I'm taking this node as my current node, and this is my previous node. So I want to change the address of my previous node to what? To the current node address. Okay, so if you change these things, then you will get this type of list after deletion. You can see this address gets changed to M. So how do we write it in a code? Java code. Okay, so for performing deletion, as usual, first we will check whether the list is empty or not. For checking that condition, we have this, right? Head is equal to null. If it is equal to null, just return some statement like list is empty, we cannot delete. Okay, so next condition, if your list is not empty, it is having some node. Okay, then the next condition you need to check is whether the head node data is containing the same data that you want to delete. Okay, that is, if I want to delete the node which is present at the first position, which is my head node. If I want to delete this node, okay, which is present at the head position, whether if you are checking whether the data of the head node is equal to the data that you are searching for to delete. Okay, if it is matching, then what you are doing directly, you are deleting this head node and you are pointing your head here to the next node, as we did in deletion at beginning. Same, you are doing deletion at beginning only. Okay, so what happened when the node is matching, when the data is matching, then you are going to delete this head node. So if you are deleting this head node, the pointer of the head node should be moved to the next node. So how do you move the pointer? Just by assigning head.next is equal to head. Okay, head, right? So you are assigning head.next is equal to what? I'm sorry, head is equal to head.next. You are assigning head.next to head, right? This is second case. Now coming to the third case. If both the cases are not matching, like both the conditions are not satisfied, okay, you have a data which is not at the head but at somewhere in between the list. Okay, that can be either in between or at the last, wherever. So but not at the head. Then what you will do in that case, if you want to delete the node, what you will do in that case? So for that, as told you, you need to traverse, and while traversing, you need to compare the data value with the node value, node data value. Okay, so here also I have taken two nodes. One is previous node and the next one is current node, because I am going to delete the current node and I want to make a change in my previous node. So for that reason, two nodes I have considered. One node is previous node, the next node is current node, and now the current node is pointing to the head node. Okay, so you want to traverse. For that you are using while loop. Okay, inside that you are checking the condition current.next not equal to null. Okay, so if the current condition is true, if the current dot next is not equal to null, what you are doing, you are assigning that current node as the previous node, the same case which we seen previously. Okay, the same way you are going to assign the current node to your previous node. Right, after assignment you are checking whether the current node data is equal to the data you are searching to delete. If it is matching, directly you are going to delete that current node and you need to assign your previous dot next as current dot next. Right, so you can see if your current dot data is equal to data matching, then what you are doing, you are assigning previous dot next is equal to current dot next. Okay, so after assigning this, what you are doing again, your current dot next should be equal to null. That is, this current dot next is there na, that should equal to null. If you make it as null only, this will get disconnected from this list. Otherwise this will be referring to this node again. Okay, anyways there will be a disconnection here, but what about this node with this node? So if you want to disconnect this node with this node, then again you need to replace this with null value. So that is what I have done here. Current dot next is equal to null. Okay, whereas previous dot next is equal to current dot next. Right, if the current dot data is equal to data, you are doing these operations. Okay, otherwise, okay, if the data is not matching, the current data is not matching with this value, then you need to traverse, you need to move to the next node, and again you need to compare whether that value, data value, is equal to the data value that you are going to delete. Okay, so for that you are using this current is equal to current dot next, that is you are moving to the next node, you are iterating to the next node. Okay, so this is how you will delete a node that is present in between the list. Right, so this is all about the single linked list operations.